All right, good morning and welcome to Master Talker online class. If today is the first day of watching our video, please click the subscribe button. Okay, in this video we'll be talking about longitude and latitude. Okay, so but let's start from a circle. If you have a circle like this, and this is the center of this circle, okay, and I have a radius, two radii like this, and this is the angle between these two radius. Okay, if you want to find it, maybe say this is point A and point B. If you want to find the distance between point A and point B, that is the length of the arc. You know that this is an arc. This is the minor arc, while this one is the major arc. Okay, so if you want to find the length of the minor arc AB, okay, the formula is simply theta over 360 times 2 pi r. Okay, why do we use 2 pi r? 2 pi r is called the circumference of a circle. That is formula for the circumference of a circle. Okay, so that is the first thing you need to know for this topic, because this formula is very, very important. We'll be using it all the time. Okay, so now I hope you know that the shape of the earth is spherical. Okay, the shape of the earth is spherical. If I have the earth like this, the earth is spherical in shape. Now let us draw our cardinal point. This is our cardinal point. This is the north, the south, the east, and the west. Okay, this line now, this one, if you draw this one, this first one like this at the middle, is called the what? The Greenwich meridian. The Greenwich meridian. Okay, meridian. Okay, why this one like this in the middle is called the equator. This one in the middle is called the what? The equator. Okay, now you need to know the difference between the Greenwich meridian and the equator. The Greenwich meridian is on the longitude, while the equator is on the latitude. Even sometimes I used to have a misunderstanding between which one is longitude and which one is latitude. Please, you know that the earth is spherical. Since the earth is spherical like this, the long one like this, which is the vertical one, okay, is the longitude. That is how I used to remember it. If I remember that the long one, which is the vertical one, I will now remember that what? That the vertical one is the longitude, while the horizontal one is the what? The latitude. And you need to know that the longitude is equally called the great circle. The longitude is called what? The great circle. So any longitude is a great circle. Okay, why? Because it's bigger than the latitude. Okay, so they form great circles. Why the one for latitude? Latitude. Okay, not really like this. Okay, can draw it like this. You see the way I drew it. You face it according to the way they are facing. If you are up, anyone you are drawing should be up. Okay, you can you cover it. If you don't like, just keep drawing it. Keep drawing like this. Okay, but if you are down, it will keep facing down. If you are down, it will keep facing down. Okay, so that's the difference between the small circle and the great circle. Now, if the angle you want to form is on the great circle, we use that what? We use that the length. In fact, we use this formula that the length on, or the distance on a great circle. Let's call it distance. Distance on the great circle. Okay, the distance on the great circle is what? Theta over 360 times what? 2 pi r. This normal one that you know. But the distance on the small circle, the only thing that you must add cos theta to it. Okay, the distance on the small circle is what? Distance on the small circle is what? Theta over 360 times 2 pi. This r will change to big R cos theta. Okay, big R cos theta. So that is the difference between the small circle and the great circle. So longitude and latitude is the simplest topic you can do in maths. Just know these three formula and you are, in fact, just know these two formula, you are good to go. There is nothing else there. So let us just draw. When we are drawing, it will not make you to understand it perfectly as you are solving some questions. Okay, so now let's talk about the distance between two angles. The distance between two angles, or the angular distance. The angular distance between 2 points on the earth. Okay, the angular distance between 2 points on the earth. The angular distance. Now, for the angular distance, that is one thing you need to know: how to find your theta. The angular distance is how to find your theta. Okay, and how do we do that? The only thing you need to note here is that if they are on the same side, you will do what? You subtract. But if they are not on the same side, you add. Very simple. If they are on the same side, you do what? You subtract. But if they are not on the same side, you add. For example, if I have find the angular distance between find the angular distance between A, and that A is 40 degree north, 65 degrees east, and B is 35 degrees south and 65 degree east. Okay, so this is very simple. Now in this thing, now there are two things that you need to find here. The first one is called the alpha, while the second one is called the theta. Okay, alpha is gotten from the one they have in common. So they have 65 east in common. So my alpha is 65 degrees. I'll tell you what to do with this alpha. But the theta, to get your theta, is the remaining one. Now, are they on the same side or in different side? If you see that they are on different side, this is north and south, they are not on the same side, so I'm going to add. So my theta is simply 40 plus 35, which is what? 75 degrees. Very, very simple. But you can decide to draw it by yourself. If you want to draw it, always have your north, your cardinal point. This is the north, the south, the east, and what? The west. So I have what? 40 degree north. 40 degree north is this is north. So I'm going to draw to the north side. I will draw to the north side and call it what? 40 degrees north. Very simple. 65 degree east. 65 degree east is this side. So I'm drawing to this side and name it what? 65 degree what? Degree east. Okay, the next one is what? 35 degree south. The south is down. 35 degrees south. I will now draw and call it what? 35 degrees south. Any other one? 65 degree east. We have already drawn it. So the point they met is that your A and B. This is the meeting point of this one. This is the meeting point of the north and the east. So this is my A, and this is the meeting point of the other one. This is my B. Okay, so now the angle both of them form is to the center. So let us draw to the center. You draw here to the center and draw this one to the center. Okay, so now what do we have now? We now have that here now is your 40, while here now is your what? Is your 35. So the angle between these two points is now the addition of both of them, which is what? 75 degrees. You see, it's very simple to get. Very, very simple to get. So let us do another one. Even without drawing this thing, you can get it. Okay, without drawing it, you can get it, but drawing it will help you if you are solving calculations. Okay, so number 2, example 2 said find the angular distance between x, and they say that x is equal to 60 degrees north, 20 degrees west, and y, which is 40 degrees north and 20 degrees west. Okay, so let us draw. But without drawing, you should know that your alpha is what? The one they have in common, which is what? 20 degrees, and your theta is what? The one, the remaining one. But this is north and north. This is 20 degree west and 20 degree west, the same 20 degree west, 20 degree west. That is why my alpha is 20. Then my theta is gotten from the remaining one. So you look at this, is not north, they are on the same side, so I'm going to subtract. So this is now 60 minus 40, which will give you what? 20 degrees. So 20 degrees is the angle, okay, is the angular distance between them. But let us show it in our diagram. So this is my cardinal point: north, south, east and west. Draw the first one: 60 degree north, 60 degree north and 40 degree north. So 40 degrees should go upper, then 60 degree north should go down. Okay, so this is 40 degree north, and why this one is what? 60 degree what? North. Okay, so you have to be very careful. Sorry, the 60 degrees should be up. It's a mistake. Sorry, the 60 degrees should be up. This is 60 degrees. Okay, why this one is what? Is 40 degrees. So the next one I'm drawing, so please, the higher the angle, the higher you take it up. Okay, so now let's do the next one. Now the next one we have is what? 20 degree west. West is in the left hand side, so I'm drawing my 20 degrees. I call it what? 20 degrees west. Okay, so this is the point they met. So this is my point X, and this is my point what? My point Y. So tracing both of them to the middle, if I trace both of them to this middle, you are tracing everything to this middle. I will trace this one to this middle and trace this one to this middle. See that this is the angle between them. So it's a small angle. This angle is smaller than these two things. Yes, they are smaller than that. So what do we do now? We are now going to get that that is why we have to subtract. So because if you look at this now, let me show you. You know, they form alternate angle. This one is 60, the first one is 60, this one is 60, and this 60 is from here to here. From here to here is that 60. Okay, why the other one is 40? This 40 is this small place, 40. Okay, so to get the angle between them is you saying the big one 60 minus this one 40. Sorry, minus this 40 to get this place. Look at how it is. Let me show you how it is. The first one is like this. Why the second one is like this? So the first angle 60 is this big man. This is the 60. That is alternate angle. If here is 60, here will be 60. Are you getting it now? If here is 60, this big angle will be 60. So if this small place is 40, this small place now will be what? Will be 40. So this one is the angle between them. So this angle between them is now what? The 60, the big man, minus the 40. So that is why we subtract whenever they are not on the same side. Are you getting it? So if they are not on the same side, please subtract. Even if you don't know how to analyze all these things, just know that you will subtract. But one thing you need to learn is how to draw it. Drawing it is very, very simple. Okay? So that is that. So the next one, they say that y and x and y are two places on the same circle of latitude 80 degree north, comma, then x is on longitude 79 degree west, and y is on longitude 11 degree east. Okay, then I say what is the angular distance between them? Okay, now this is very, very simple. So what do you do in this case? Solution. Now, even if you don't want to draw it, for the fact that they say that x and y are on the same latitude 80 degree north, so it means that the latitude that they have these 80 degrees in common, like we always say, and the common one is your alpha. So my alpha is what? 80 degrees. So how do you get your theta? Your theta is now gotten from the remaining one, and the remaining one is what? 79 degree west and 11 degree east. West and east are not on the same side, and I told you that if they are not on the same side, you just have to add. So I'm going to say what? 79 plus 11 degrees. So my answer will give you 90 degrees. So 90 degrees. So the distance between them is the 90 degrees, not the alpha. I will still tell you what to do with the alpha. So but the distance between them is the 90, please, not the alpha. Okay, let me even write it. The distance between them is equal to that theta, and it's equal to what? 90 degrees. Okay, so but let us draw it so that you understand it very well. So drawing it, let us draw it. You put your cardinal points, my north, south, east, and west. So they say that they are on the same latitude of 80 degree north. So this is my 80 degree north. 80 degrees north. Okay, then the other one is on latitude of 75 degree west. This is west. The longitude of 75 degree west. This is west. So I'm drawing my west from here to here, and name it what? Name it 79 degree west. So the other one is 11 degree east. East is on the other side. 11 degree east. 11 degree east. Okay, so this is the meeting point now. This is the meeting point, and then you trace it to the center. This is the meeting point. You trace it to the center. Now the angle, that angle between them is here and here. So how do we get that? Is here now. This is the angle. Okay, and this angle is this angle is 79, and the alternate angle will give you that they are z. So if here is 79, here will be 79. Okay, so here is what? 79, and the other one, this is the angle between them, which is what? 11, and if here is 11, automatically here will be 11. So the angle between them is here and here. That is why we add 79 plus 11. Okay, so that is the reason we add. So I hope you got that. Okay, the next one. All right, so now let's talk about distance on great circle. Distance on great circle. All right, please, you need to note, please, that formula I gave you for distance on small circle, which is theta over 360 times 2 pi r cos. Please, that should be cos alpha, not cos theta. So this is where we use alpha. We use alpha for small circle. I just remembered it now. Okay, so when we solve question, you will really understand. So I told you that distance on great circle, the distance on great circle, that is the length of the arc. Okay, so distance on great circle is given by distance on great circle, and don't forget that great circle is what? The distance on what? Whenever the distance is on what? Like, okay, hey, let me show you now. If you look at this, the distance between, this is the point x and y. You see that the distance between x and y is on the latitude. Since it's on the latitude, it is distance on the what? On the small circle. In fact, let me draw it for you. Distance on a great circle is, for example, if I have my cardinal point like this, let me make you understand it very well. This is north, south, east, and west. Okay, maybe I have something like this and another one like this, and then I have a common latitude. Okay, now this is point, let me say this is point x and this is point y. If you look at the distance between x and y is on the longitude. So if it's on the longitude, we call it distance on the great circle. So you need to know the difference between distance on the great circle and distance on the what? Small circle. Another one, maybe you have another one that moves this way, and maybe here is point A and here is point B. If you see that the distance between point A and B is from here to here and is on the longitude. Since it's on the longitude, we call it distance on the great circle. You understand it now? But watch this one now. The distance between x and y here is on the latitude. And since it's on the latitude, we call it what? Distance on the small circle. You get it now? I hope you get the point now. So that is that. So, and the formula for great circle is simply theta over 360 times just 2 pi r. Very simple. Okay? So let us solve question to illustrate what we are doing. Question number 1. Let me use big R. And what is R? Don't forget that your R is equal to what? The radius of the earth, and the radius of the earth is given by what? 6,400 kilometers. Please don't forget. Okay, 6,400 kilometers. So let's go. Y and Z are 2 points on the earth's surface. 2 points on the earth's surface along the meridian, such that Y in bracket of latitude 70° north, comma, longitude 65° west. Okay, and Z, they gave me Z as latitude 38° south and longitude 65° west. Okay, then I say calculate the distance. Calculate the distance YZ. Okay, calculate the distance YZ, right? So now, first of all, you can decide to draw it if you want to draw it, but without drawing it, you will know that even without drawing it, that your what? That your alpha, though we don't need alpha here, but let's just get it so that it will be for you will be familiar with it. That your alpha is the common one, and my alpha is what? 65. Very simple. Then my theta is now gotten from the remaining one, and this is south and north. They are not on the same side, and if they are not on the same side, I'm going to add. So I'll say that this is equal to what? 70 plus 38, which will give you 108 what? Degrees. Then to get your distance is simply theta over 360 times 2 pi big R, which is what? 108 over 360 times 2 times, we can use 22 over 7 or 3.142 times 6,400. Please don't forget that your R is 6,400. So if you do that, you are going to get that the distance is or it depends, you can just use pi, anyone you like. Let me put my answer in terms of pi, but anyone you like is still correct. 3,840 pi in kilometer. That if it depends on the option you are seeing there. If their own is in pi, you leave your own in pi. If their own is not in pi, you put pi as 3.142 or 22 over 7. You see, I got the answer without drawing it, but let us draw it so that you understand it. So drawing it, my cardinal point: north, south, east, and west. Okay, now in fact you need to draw it so that you will know that whether whether you are using formula for great circle or small circle. Please, or just know that if the longitude are the same thing, then the distance must be on the great circle. Yes, very, very important. If your alpha is gotten from the longitude, that is, if the longitude are the same, okay, then it is what? Distance on the great circle. But if the latitude is the same, then it is distance on the what? Small circle. But let us draw it so that we understand it better. 70° north. This is my north. I will draw it and name it what? 70° north. Very simple. Now 65° west. West is in left hand side. I will draw my west. 65° west. 65° west. Okay. Now the last one is what? 38° south. South is down. You make it face down and name it what? 38° south. Very simple. Now this is the meeting point, and this meeting point is your Y. This is the meeting point, and this meeting point is your Z. So trace them down to the center. If you trace them down to the center, you'll be getting that this small place is the what? Is the 70. While this small place is what? Is the 38. So the angle between them will now be the addition of both of them. You see that the distance between X and Y falls on the longitude. So that is why we are using the what? The formula for what? Distance between distance on a great circle. Okay, so that is why we are using that. So note, you should note, very very important, that if your longitude are the same thing, then the distance formed must be on the great circle. But if your latitude are the same thing, then the distance formed is on the small circle. Okay, so let me check my time as we forge ahead. Okay, we still have time, so let's continue. The next question said an aircraft flew from city A in bracket of 0 degrees comma sorry latitude 0 degrees comma and longitude 0 degrees. Okay, then I said another okay from here to another city B, latitude 0 and latitude 0 and longitude 18 degrees. Okay, then I said at an average speed of 1000 kilometer per hour, then I say calculate the distance traveled. Solution. Now this is very simple. Okay, we can draw this. Even if you don't want to draw it, you will know that this is distance on a small circle. Yes, because if you look at it, you will see that your latitude are the same, and if the latitude are the same, then it is distance on a small circle. So we need our alpha, very important. So our alpha is that 0 degrees, while our theta is 18 degrees and 0 degrees. So even if you subtract, you will still get 18 degrees. Okay, so now, but let us just draw it. Let me just draw it. Drawing it, I have my cardinal point north, south, east and west, and they say that the latitude is 0, so we are not drawing, but the longitude is 18. So I will draw my 18. The longitude is 18, but the problem here is we don't know if we are drawing it to the east or to the west. But let's just draw anywhere, sir. Let's just take it to be here, for instance. Okay, so if the latitude is here, if the longitude is here, so what do we do? So where did they meet? An aircraft travel from city and okay at 0. Okay, let me say that these are the 2 points at 0. This is my origin. These are the 2 points. Okay, at 0, because the first one is 0, this first one is 0, which is this long line. Now this is the 0 here, so 0 and 0 meet here, so this is my point A. Then 0 and 18 met here, this is my point B. I told you that since the latitude are the same, this is distance on a small circle. Are you seeing it? So that is that. So what do we do now? Let's calculate. In our calculation, you know that distance on a small circle, we are supposed to use that word, that distance on a small circle equals what? Theta over 360 times 2 pi big R cos alpha. And cos 0 is what? So let's do, this is what? 18 over what? 360 times 2 times 22 over 7 times 6400 cos 0. And cos 0 is 1. So if you do everything, you are going to have 2002 what? Kilometer. So that is that. Okay, So in our next video, we solve more questions on distance on a great circle before we now enter distance on a small circle. So thank you very much for watching. Please share to anyone that needs to watch this, and like, comment, subscribe once again if you have not. Bye bye.